Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be talking about 8.2, the title of which is Inscribed Angles and Circles. Before we get into inscribed angles in a little more detail, we're going to take a minute, step back, talk about parts of a circle and all kinds of lines that can go through a circle. We'll be using this throughout the rest of Unit 8, bleeding into a little bit of Unit 9. So without further ado, we'll go ahead and get started. So with circles, there are all kinds of lines that we can draw through here. Of course, the first couple lines that you learn about when you're dealing with circles are, of course, radius and diameter. And this goes back to middle school, but maybe it's been a while, that's okay. So in a circle, you always have a center-ish. And through that line, if I draw a line all the way across, going through that center, that is a diameter. So the diameter goes to the ends of the circle, going through the center. More specifically, it's connecting the outsides of the circle going through the center. And you can draw any number of diameters. So that line is a diameter. I could go up and down. This line would be a diameter. The only distinction is that it's a line that's going all the way through the circle and it's passing specifically through the center. So anytime we have that type of line, that is referred to as a diameter. Now if we take half the diameter, which means we're only going from the center to the outside, then that is a radius. So going from the center to the outside of the circle, that is a radius. Those two we're probably familiar with. In 8.1, we then introduced the idea of a secant line. A secant line is a line that is outside the circle that is intersecting the circle at exactly one point. So here, for instance, if it's only intersecting the circle at one point, then that is a secant line. We have other lines that we can kind of draw through and in and around our circle that we want to be familiar with. Those are what's known as a chord, is the most common. So a chord is a line that's going inside the circle, but it is contained in the circle. So for instance, if I had a line segment that was going, say, from here to here, for instance. It's contained inside the circle, but it's not passing through the center. That is an example of a chord. And we didn't cover secant last time. We covered tangent line. Sorry, let me correct that here. Whoop. That is tangent line. Getting a little ahead of myself. And then an actual secant line is a line that is intersecting the circle at exactly 2 points. So for instance, if I drew a line, let's say going from here to here, it's intersecting the circle at 2 points. So that is an example of a secant line. Okay. So these are all different lines that we can draw through our circle. A couple of the questions in the notes and in the assignment are going to ask you to define each of those. Now, when we draw lines that are contained inside the circle, we end up with different types of angles. We also want to be able to define these different angle types for this assignment. So, when we are looking at a circle and we draw an angle, we'll draw another circle here. When we draw an angle here, and let's say we'll start out with a central angle here. A central angle, as we defined in 8.1, is an angle that is starting at the center, so the vertex is at the center, and it is connecting the circle. So this here, that would be our central angle. And this can be bigger, this can be smaller. The only contingency is that the angle is centered at the center of the circle at the origin. Now, from here, looking on the outside, we have the outside of the circle. The entire outside of the circle we know is the diameter. However, if we are breaking the angle apart, we end up with two parts of the circle. We have the first part here that is intersecting our central angle, this measurement here. And a part of a circle we refer to as an arc. If it is less than 180 degrees, like it is here, we refer to that as a minor arc. Because technically there are two arcs that are formed when we make an angle. Of course, we are used to thinking of this as being our angle, right? That's contained inside, but we also have an angle that's going the other way. So the other part of this, the larger part, we refer to as a major arc. So this whole thing here, that is a major arc. So these are sort of all the parts of a circle that you want to be familiar with so far. So diameter, radius, tangent, chord, secant, and then we have minor arc and major arc. Okay. So we know all of this. There are a couple theorems in this section that we want to be familiar with. We'll start with looking at this right circle here. When we draw an angle, typically so far we've been measuring in degrees. At the end of Unit 8 we're going to talk about another way to measure angles, but degrees is our bread and butter. There is also a way to measure arc. Now, there is a way to measure the arc length. Sometimes we want specifically the length of the arc, sometimes we want just the angle measurement of the arc. Okay? So basically, if you have a central angle drawn, the measure of the central angle is going to be equal to the measure of the minor arc. So you'll have a few questions like this on the assignment. And again, let's call it QRQT. So if I tell you the measure of angle RQT is, say, 90 degrees, then the measure of the arc RT, drawn as such, would also be 90 degrees. If I asked you for the measure of the major arc, then we would have to have some other point here to indicate that we wanted to measure the major arc. So for instance, let's say I threw another point on the circle S there, then the measure of arc RST would indicate the major arc, and so it would be 360 minus 90, which would be 270 degrees, like so. That's the first theorem that you want to be familiar with. There's a couple questions that are like that. From there, we look at the title of 8.2, which is looking at inscribed angles. So inscribed angles are kind of funny in that no matter where we draw them, they end up being the same measurement. So in a lot of textbooks, including ours, you'll end up with shapes that maybe kind of look like so. So we'll have a circle. We're going to have a central angle drawn, like so. And then about that, we'll take a couple points. Let's say, I put a point here, and I'm going to draw the inscribed angle. Remember, the inscribed angle is inside the circle. So let's say I have it going like so. And there might be some overlap, that's okay. But the endpoints of these two angles are the same. So let's add some letters here. We'll call the center O, and let's call this A, B, C, and then AOC. Okay. What we find is that the measure of the inscribed angle So the measure of the angle that is inscribed is half the measure of the central angle. And this is one of the theorems in your book. So if I give you the measure of the inscribed angle, you should be able to tell me the measure of the central angle, and vice versa. If I give you the measure of the central angle, you should be able to tell me the inscribed angle. So for instance, let's say I said that the measure of angle AOC is 40 degrees. I could ask you, well, what's the measure of angle ABC? By definition, it's half of that central angle, so it would be 20 degrees. And if I asked you to go the other way, let's say I said the measure of angle ABC was 15 degrees, and asked you for the measure of angle AOC, well then that means it's double, so 30 degrees. That's pretty much all you have to do in this assignment. There are a couple questions, just like we did in 8.1, where instead of showing you an angle measurement, I might throw in a little bit of algebra, maybe throw in an x. So I could say, the measure of, use the same diagram here, measure of ABC is 2x, the measure of AOC is 4x plus 10. Make it a little bigger here, 4x plus 100, and solve for x. Okay. So if I ask you to do that, well then you've got to use this formula that we wrote to set that up. The inscribed angle is 2x, and that's equal to, of course, let's change this, I'll make this 4x also. So 4x is equal to 1/2 of the central angle, which is 4x plus 100. Distribute 4x equals 2x plus 50. Subtract 2x on both sides. Divide by 2. So you're either telling me what the angle measurement is, or you're using these relationships to solve for a missing value, just like we did in 8.1. That's it for today. If you guys have any questions, please reach out to me. Otherwise, have a good day. I will talk to you soon. Bye.